Okay, so we're going to assume we've got a loaded beam with this moment of inertia rotating at this angular velocity. This is a vector angular velocity with a k. K being perpendicular to the plane in which the beam is rotating. Okay? And as I just said, we're not talking necessarily about the beam we've observed in the lab, which is on a stand and subject to gravity and all kinds of stuff which keeps it stable. It's out there in intergalactic space, merrily rotating, and whatever its plane of rotation is, K is perpendicular to that plane, right? By the right-hand rule. Okay? So, there we have it. That's the beam. Now, along comes a slow meteor. Meteorite. Okay? With a moment of inertia of 0.07 kilogram meter squared. Okay? And we can't expect that meteorite to be coming along in a direction that measured relative to the axis of this thing's rotation, or whatever axis we're measuring this about. We can't expect it to also be in the k direction. Okay? So without going into the details of how we would calculate that, which aren't that bad, but omega m turns out to be three radians per second, okay, multiplied by this. Okay? Actually, 6 and 0.6, so 2, do that. This isn't exactly a unit vector, and it'd be convenient to make it into one, but I didn't have a convenient unit vector in three-dimensional space handy in my morning brain here. So we'll just go with this, okay? Because it's perfectly valid. Okay, so this is a magnetic beam, and this is a magnetic meteorite. So they come together, okay? Or meteorite just happens to bump into it and be covered with some kind of intergalactic glue.
Actually, in space, if there's no, like for example, meteors that are made of the same material, when they collide, they cold weld immediately.
They what?
They cold weld. So if you have two chunks of iron in space that have never been oxidized, they'll combine.
Well, they'll combine because in intergalactic space, generally, they're moving really fast and they just kind of melt together. All the parts of them go flying off, right? That's not the case here, because you have a slow meteorite in a beam, right? They're not going fast enough to melt together, okay? And that gets complicated because you get fragments and stuff like that, so we're not going to try to analyze that, although we could, okay? And you've already had problems where you have shells exploding and conservation of momentum, right? They've been assigned, pretty sure. If they haven't, they will be. Okay, so, question now, what is omega F? Go ahead and work it out real quickly.